Chapter 6, Enzymes. In this chapter, we're going to be studying the proteins, the globular proteins that we refer to as enzymes. Enzymes are responsible for doing the work of the cell, the catabolic and anabolic metabolism of the cell. Because of this, we think of enzymes as catalysts. Okay, you think back to your chemistry courses. A catalyst is something you add to a reaction to initiate it, to make it occur. Well, same thing here in a biological setting. Instead of adding in, some type of a metal or something like that to the reaction mix, we're using a protein that is going to make a reaction happen faster. Not a reaction that wouldn't happen on its own happen, but something that could happen, but the time scale, the time frame that it would happen is too slow. Look here, and it's talking about reaction rates. The rate of reaction is the time frame, seconds, minutes, hours, days, weeks, months, years, whatever it would take. Well, an enzyme takes that and shrinks it down. So now instead of hours, days, weeks, months, years, it's minutes, seconds, milliseconds, microseconds. Enzymes are highly specific. Okay, has to do with that. You have the overall protein, has to do with that active site. Active site has a specific shape due to, the tertiary structure of the globular protein. The R groups from those amino acids that make up the secondary structure, those R groups are pointed into that active site, and only a true substrate of the correct shape will not only be able to fit into that active site, but fit into it in such a way that the R groups of those amino acids can interact. As I said, that specialized pocket, that active site, it's where the specificity for the enzyme occurs. The work of the enzyme is going to be done in that active site. The twist, the tweak, the cut, the paste is going to occur there. The R groups that are going to, of the enzyme amino acids, are going to be interacting with the substrate. Now there's going to be a lack of covalent bonds, but there's going to be a lot of hydrogen bonds, ionic bonds that are going to push and pull, stress bonds within the substrate. So this interaction is going to take the substrate, and you have the substrate and the enzyme interacting, and this is going to be what is referred to as a transition state. As that enzyme is taking the substrate and modifying it to become a product, the enzyme and the substrate are interacting so tightly and in such a way that we now are entering what is called a transition state. Bonds are stressed, bonds are being made and broken. Evolution has slowly selected for enzymes that function in such a way that they facilitate the required metabolic reactions. If you have an organism that has an enzyme that takes substrate 1 and turns it into product A, it does so, but it does so very slowly. Well, product A may be needed for something very important. Well, you take that organism and you compare it to another organism that has a slightly modified enzyme that takes product 1, turns it into product A, but it does it a little bit more efficiently. Turns out that the enzyme in the second organism, there was a slight mutation. That means its active site, has a better specificity, has a slightly tweaked, better ability. Not great, we're not talking leaps and bounds, just a little bit better. Second organism's going to survive better. Well, you stretch that out over millions of years, which that's the time frame we measure evolution on. Yeah, evolution is going to give you a little bit better every species. And we're going to find that in this chapter. We're going to talk about and discuss that there's regulatory mechanisms. I mean, yeah, translation itself could be a regulatory mechanism for some enzymes. That's for a metabolic pathway, metabolic process that may be only needed once in a blue moon. But if it's something that's going to be needed on a daily basis, but just not every moment, every hour of the day, you want to have a way of fine-tuning it, turn it up, turn it down. You don't want to have it there and get rid of it and then have to wait a couple hours to go through transcription, translation, and modification all over again. So we have some fine-tuning. Turn it up, turn it down with different modulators, activators, inhibitors.